Okay, hello everybody. Hope you can all hear me okay. Please, if you can ensure your microphones and cameras are off and muted. I'm going to try and record this session, so that should be available on our website at some stage in the future if the recording works. So it's the first time I've tried to do that, so you have to forgive me if it doesn't quite work. And also, I have to keep admitting people into the lobby as well. I don't quite know why I have to do that. I thought I'd have been set up so that wasn't necessary. But anyway, there's a chat button that you can use on the show conversation button. So if you'd like to use that, Mary Claire will coordinate the any questions that you have or anything like that. Okay, I think that's about it really. Let's have a look at what we've got. So okay, so I think you all know quality management and training. I think you're all aware of quality management and training, but anyway, established in '84, been provider of products and services since then. Registered as accreditation centre with CQI, and offering such things as auditing and quality assurance, quality management, environmental security, health and safety, etc. Won the best student award, and I think we've got a reasonable reputation in terms of providing quality assurance training and the like. Okay, latest news. All of our courses now can be delivered via over video conferencing. So we can do all of our courses and have been now doing most recent one being inspection techniques courses, and also we can there are a number of new CQI IRCA certified courses as well. So I think if you take a look at our website, you'll find some of those courses, and on our website you can see here you should be able to find any of the new IRCA CQI courses that may be of interest to you, providing you with a qualification, CQI qualification.
And you'll be fully versed in
so just about me for a few minutes. I'm
activity resulting on the sense.
Let me just mute everybody because I can hear people. Mute. So I'm CEO of Quality Management and Training Limited, quality manager for numerous organisations, associate lecturer at Surrey University, and I've written 1 or 2 books on quality assurance. Okay, that's enough of that, I think. So the webinar is going to be based on specifically Introductory to Risk Management Foundation Level FD103, and although he won't be able to cover, it's only an introduction in this case to an introduction, so we won't be able to cover all of the things in the risk management course. That covers a number of other risk management techniques, which I'll mention as we get a bit further into the session. But it is based on that FD103. There are other open courses as well that you can attend that are also provided over video conferencing as well. There's failure mode effects analysis and fault tree analysis, and there's other risk analysis techniques, but they're the 2 main key ones that most people are aware of. Most people use, FMEA being by far the most popular. So let's have a look at what we're going to cover today then. So we're going to have a look at why FMEA. We're going to have an overview of FMEA. We're going to have a look at a procedure for conducting a product FMEA. We're going to have a look at a method, an approach for doing a process or project or a process FMEA. We're going to have a look at other risk analysis techniques very briefly, and we'll do a little review then of FMEA, and we'll have a look at what questions we've got at the end of all of that. So the objectives are to understand that FMEA is a preventive approach. It's not a corrective action approach, so it's not meant to be something, although people do use it this way, it's not meant to be something that we use rushing around after the event. So it's not meant to be a root cause analysis approach, although some people do use it that way, or a corrective action approach. It's meant to be preventive, so we're trying to prevent things going wrong in the first place. Part of our quality management system, if you like. Yeah, it's supposed to be at the front end, not the back end of problems. Should understand the importance of FMEA. You should be aware, I don't know whether you'll be able to conduct a product and process FMEA, sometimes known as design FMEA, as a result of this session, but we'll see anyway. You should understand the individual's roles and responsibilities when conducting an FMEA, and you should be able to just about create an action list of things that you perhaps might want to do as a consequence of this session, of this webinar. So FMEA then is, to give it its proper title, it's FMEA is it's failure mode effects and criticality analysis. So and the C stands for the criticality, because with FMEA, you create a number with it. It's a risk priority number, and it's that criticality, that C, that it's referring to, because we can do FMEAs without doing the calculation of the numbers as well. My FMEAs are in truth an FMECA, and that's the correct title for them. So they should really be called an FMECA, criticality analysis. But for shortness, I'm just going to continue to use the term FMEA. And anyway, most people use that term anyway. It's a logical technique to use to identify and eliminate possible causes of failure. The technique requires a sequential and disciplined approach by engineers or process owners. So it's not just a manufacturing technique. It can be used by for other processes as well, sales order processing, medical processes, drug processes. So it's not just manufacturing, and it requires engineers or process owners to assess systems, products or processes in order to establish the modes of failure and the effects of failure on the system, product or process. So this enables that all possible failure modes have been fully identified and ranked in order of importance. The FMEA discipline requires engineers and process owners to document their evaluations with regard to the failure mode, the effect of that failure mode, and its criticality. The analysis can be applied at any stage in the process, so it could be at the design of the process or design of the product. It could be at the manufacturing stage, it could be at the test stage, it could be installation or use. So we can apply it to all of those things, but when to do it is probably at the front end of any design process, new design process, or change to a process. That would, generally speaking, be the best time to conduct an FMEA. So generally speaking, it can be a system study. So it can be a system study in the sense that if you think about brake shoes, so if you want to do a risk assessment on the braking system of a car, then we could start with the brake shoes and build it all the way up until we've completed the complete braking system of a car. So it can be used initially at sub-assemblies or sub-processes, and then built up through those sub-assemblies to cover all of the car. In fact, most car manufacturers and aerospace manufacturers demand that FMEA is conducted associated with their products that they're going to be delivered. We've been involved in it for aircraft control, for software projects, for sandwich manufacturers, for car manufacturers, for jet engine control, for soup manufacturers, and etc. So we've been involved in it in lots of areas. So it's a logical technique used on products, devices, systems, or processes to identify and eliminate causes of failure. It's sequential, so there's an approach, there's a sequence of steps that we need to follow to establish the modes of failure, their effects of failure, establish the risk priority numbers, rank those things in order of importance, and then to carry out some corrective action as a result to eliminate or mitigate those effects. There's a number of reasons why people might want to conduct these FMEAs. We might want to retrieve right first time quality, and there are greater pressures on design and process owners to ensure that we get these things right first time. So it identifies, FMEA will identify any inadequacies in the development of the product or the process. Sometimes we can't run the process without having created it. And so we need to do an FMEA so that we don't get any nasty surprises associated with our process when we run it. And similarly with our product as well. We can do tests and trials on our product, but they may be only limited to 1 or 2% of the products, and 1 or 2% doing trials on 1 or 2% of products is not going to identify low field failure rates. So where we want to achieve low field failure rates, then and we can do tests and trials, but that won't always be successful in identifying all of the problems with the product or process. We might want to do FMEA for regulatory reasons. There's a regulatory driver sometimes for these things. CE marking and medical device requirements sometimes demand FMEAs to be performed. It's a continuous improvement, so we're trying to make sure, as I've said before, right first time. So it's a continuous improvement approach, and it's preventive rather than corrective, as I mentioned earlier on. Sometimes it's required by procedures, so it may be that your introduction of a new product or a change to a product, or introduction of a new process or change to a process might require that there by policy that there is a procedure associated with that, and that we must do we're required to do an FMEA there, or risk assessment there. It's applicable to manufacturing and service industries, so it's not just a manufacturing approach, although it came out of, I think I'm right in saying it came out from Ford in way back when they wrote their Q101 systems, and that's where it originated. I think that's where it's originated from, although I'm not absolutely sure about that. Certainly that's when I bumped into it the first time. It's useful where we've got little or no data, and it's useful where the problems are sporadic. So if you want to achieve zero defects, it's one of the tools that we might want to use to achieve zero defects. So we would want to use it in new products and new processes, and it's a team building exercise as well. So although I've known single people to do FMEAs. In fact, there was one guy I know, having had the previous FMEA course that we ran, decided to back at the ranch to do an FMEA on his product, and they stopped the product launch. It was a viscometer, and they checked the viscosity of quite nasty materials like blood and stuff like that. So and the problem with it was, very simply, it could be knocked over because it was unbalanced, and they stopped the product launch as a consequence of that. But generally speaking, we would want this to be a team building exercise. So it's normally more than one person that does it, but it doesn't have to be. So it provides the potential for reducing customer complaints, campaign changes, warranty costs, safety failures, extended life or reliability failures, product liability claims. And generally speaking, we would want to use it for, as I've already kind of mentioned, quality assuring new product introduction or change, new process introduction or change, so any changes to key processes, for bought-in products, and services. This may be something that we demand of our suppliers, that they conduct an FMEA on their products and services. We did this for a company that wanted to move their factory for making soup from London to Peterborough, and they wanted a turnkey factory. That the minute they switched their soup making factory on, it worked, and so we together with the suppliers of the equipment did quite a considerable number of FMEAs to make sure the factory did turn on first time. We can do it on capital equipment, so on capital equipment purchases, big purchases, where again where we're buying massive pressure cookers and things like that. We want to do FMEAs on filling machines, where we're buying capital equipment. More probably, we want them, the suppliers of this equipment, to do it. So it may be a demand that we put on our suppliers that they provide us with the results of their FMEA to convince us that they know what they're doing and they've got the right quality controls in place and understand what the potential risks are. The analysis can be performed by anybody, really. More likely it's going to be the researcher, developer, the designer, the manufacturer, or the quality person, the person that knows the system, product, or process best. So product owner as well. Generally speaking, as I've said, it's a cross-functional team, but it can be just done by one person just sitting at his desk and taking that product or process and evaluating it. The benefits are it identifies potential and known failures, which seems a bit strange. If it's a known failure, Geoff, you know, then we know about it. What more do we need to know? Well, what's blindingly obvious to a nuclear physicist is not necessarily blindingly obvious to me. And if we're looking at a nuclear power station, then I want that information trickled down to the people who are operating that power station. So it may be known to the designer of the product, but it may not be understood by the manufacturer of the product. And so we need to this mechanism of transfer of information to say there are potential risks here, maybe even health and safety risks. So identifying potential known failures is very important. It identifies the cause and the effect of that failure mode for what the customer will experience as a result of that failure mode. And so we can we then will be able to evaluate if we've got a potentially risky, serious situation on our hands. It gives us the risk factors and it measures those risk factors, giving us some numbers. And I'll talk about numbers a bit later on as well, and typical numbers that we would expect to find from our FMEA. It gives us follow-up action. So in other words, where we've identified these high critical numbers, then we can identify what action we've taken either to eliminate or to mitigate the effect. It provides documentation for quality audit. I remember doing an audit once on a furnace manufacturer. They made hydrogen embrittlement furnaces, and I chatted to the guy about the work he was doing, and he was the designer of these furnaces, and I said, what do you do here then? Well, he says, I design furnaces. Oh, that's interesting. And how do you do that? Well, I do the drawings for them, and I produce drawings, and they're made downstairs. So it's pretty straightforward, really. Okay. And does anybody check your drawings? No, nobody checks my drawings because I'm the only person here that knows how to do hydrogen embrittlement furnaces. There's no point in doing any checks on my drawings. What about calculations? Oh, yeah, I have to do calculations as well. Flow rates, hydrogen flow rates, because it's full of hydrogen, the furnaces. So he said, so I have to do calculations on those things as well. I don't suppose anybody. No, nobody checks my calculations, said the engineer, said the designer. Nobody would understand them anyway because I'm the only person here. So I was a bit puzzled to know what to ask him next. That wouldn't elicit the answer, well, I'm the only person who knows anything about them here. So I said, well, are there any safety issues associated with your hydrogen embrittlement furnaces? And with that, he rocked back in his chair for a few moments and sat back, and he said, well, Geoff, they do have the potential to blow up. Yes, sorry. Yeah, they're full of hydrogen. They can blow up. Have you ever? No, we've never had any blow up, thank goodness. But we have had a few leakers in our time. I said to him then, I think, have you ever heard of risk assessment and FMEAs and anything like that? So yeah, I think we're still doing FMEAs there to this day, thank goodness. So checks on decisions, positive and negative. And that's quite important in the sense that positively we identified it and we did something about it, or I identified this issue and management chose to do nothing about it. There's converse of that as well, and that's down to management if they don't want to do anything about it. But I did identify it, so positive. Or there's the negative, so there's the carrot, but here's the stick. Hands up, I missed it. Should have seen it, missed it. Didn't notice it, but yet we had this problem as a consequence of missing that particular risk. So it makes accountability clear. But you're damned if you do and you're damned if you don't. But we'll look at limitations of FMEA a little bit later on as well when we get a bit further into the presentation. It makes accountability clear. It's a tool used for conducting reviews, so it's laid out in front of us. As a assessor, I don't know if you've ever looked at any FMEAs that have been produced, but it's really quite easy to even though you know, what do I know about contact lens manufacture? Well, absolutely nothing. But I can look at a process FMEA, and you can pretty much tell whether it's been done properly or not. Continuous improvement and part of the validation and verification process. It's a living document used to data and quantify these RPN, risk priority number estimates. So it needs to be maintained. What's the overall process then for doing FMEA? Well, here we've got a block diagram showing the overall process. So the first stage, the 6 most important words in any quality assurance initiative is management commitment, management commitment, management commitment. And so we need to start there. So we don't do FMEAs unless we've got a commitment to doing it. And that might be a procedure, it might be going on a training course, it might be whatever. So we need some sort of commitment from management that it's important that we do a risk assessment. We need to select our FMEA candidate and pick with the berries the sweetest where we think the potential risks are. We need to do the logistics, which means to got to get together all the data and drawings and the like to put those together. We need to, I'm going to go into much more detail as I get a bit further into this, but this is just an overview of the steps. We need to draw a block diagram associated with our process. Well, we don't have to, but it's sometimes advisable to. So, for example, this organisation makes flexible printed circuit boards. I don't know if you know what a flexible printed circuit board are, but you've certainly used one. They're in cameras, they're in phones, they're in coffee making, big coffee making dispensers, chocolate dispensing machines, and all those sort of things. But this company made flexible printed circuit boards that stuck on people's chests, and so you could connect to them to measure certain measurements about them. So if so we need to understand sometimes, if I'm a flexible printed circuit board manufacturer, what the application is going to be to do an FMEA. And so to do that, sometimes we have to provide ourselves with a block diagram to enable us to understand those things. Although very often that's not available, and very often the subsidiary downstream manufacturing and suppliers are not aware of what the product's going to be used for. So, but it's sometimes advisable to try and get hold of that information so we can at least understand some of the product applications. Then we can do an FMEA, look at corrective action and corrective action and follow-up action after that. Let's have a quick look at a block diagram before I get into more detail associated with actually conducting the FMEA. So we'll have a quick look at a block diagram. So this is a, as I said, so if you're a supplier to perhaps the health service of your flexible printed circuit boards, then you don't know what those things are going to be used for. In this case, they were sticking on people's chests, or eventually they were after they've been repackaged and all the rest of it. And so we need to understand what the processes of using these things are, and we can use this block diagram method to give us some clues as to what the applications are of our products. Again, it's not essential, we don't have to do this, but it does help if we in certain parts of our analysis, if we've got this type of information. It's not essential, but we can do it. And here's a block diagram. So it may be that, and this is for a chemical facility mixing 2 raw materials together in a vat and heat them, we've got the finished product. So we might want to do an FMEA of this overall system. We might also want to do an FMEA on each of these individual components associated with the process as well. So let's have a look now at the procedure associated with doing an FMEA. So that next box along, which is let's conduct the FMEA. So we've got to do the and again, I'm going to do this in layers. So I'm just going to give you an overview, going to look at the form, then I'm going to get into a bit more detail with the form, then I'm going to get a little bit more detail again as I get a bit further into it. So we're going to kind of do it in layers. So I'm going to give you the first overview layer, if you like, of the procedure for doing FMEA. So first step is to put together all of the documents that are required for us to do our FMEA. So that means we've got to get the input documents together, the drawings, the field failure rates, all that sort of stuff. We've got a fair bit of logistics to do to choose, and including choosing our product or process that we want to evaluate. So we need to choose the product or system or item that we're going to initially evaluate. Going to do the overall system, or we're going to break it down a bit. Might be a bit too ambitious to do the overall system, so we might want to do an FMEA on a smaller item. We then complete the header details on our FMEA form, which I'm going to show you in a second. We then describe the product pass system and system. We describe the function of the part. We describe the anticipated failure mode. We describe the effects of that failure mode. Then describe the causes of that failure mode, and then identify any relevant documentation that would avoid this problem, the quality control documentation that might avoid this problem. So we do that on our forms. Here we've got an FMEA. This is for a design or a product FMEA. It means the same thing. We can fill in our header details associated, the FMEA lead, who's doing it, the part number and all those sort of things, and the version. So if this is the first one that's been done. So we then detail the component function here, the potential failure mode here, the effects of failure mode here, the possible causes of failure mode here, and then here we've got the current controls, procedures, if you like, that we've got in place that will either prevent that error occurring or detect it, or we may not have any procedures at all, and so there'll be nothing in these boxes here. We then identify, then we calculate the severity, if it does occur, the likelihood of occurrence, and our ability to detect it before it leaves the factory. So, and those are numbers, 1s out of 10, which are adjacent to the column that they're referring to. So the effects, so the severity is to do with effects, the causes, the likelihood of occurrence is the possible causes, and our ability to detect it is based upon the controls that we've got in place. We multiply those three numbers together to give us a risk priority number. So we can use this form then to complete our FMEA. Let's, again, I said there were going to be layers. Let's go into a little bit more detail on filling that form in now. So as I said, we fill in the header details, and in the component function, we detail the primary function and secondary function of the component that's under evaluation. And we use this verb noun approach. So, for example, to describe function. So we use this verb noun approach to describe function. So that function might be for a screwdriver, say. So if we're taking a screwdriver, what's the primary function of a screwdriver? Well, it will be you could say to screw screws, but its primary function is to transmit torque from your hand to the screw. So we use this verb noun approach, but also there may be a secondary function for a screwdriver. So if it's an electrician's screwdriver, it could be insulates user, so from an electric shock. So we could need to identify all of the primary and secondary functions of a screwdriver or a particular part that's under investigation. We might say a secondary function of a screwdriver is opening tins of paint. So use as a lever might be a secondary function as well. Here we, in the next column, we list adjacent to that component function how the item, the product, the component could fail to meet its intended function. And we could list all these out. So not just it didn't transmit torque, but we could brainstorm a series of reasons as to why this, did it break, bind, corrode, wear, short, list out all the reasons how that could fail. Next, we detail associated with that particular failure mode, the effects of that. What will the customer experience as a result of that failure mode? Will the car fail to start? Will the car fail to stop? Will we customer experience a 5-volt electric shock? Will the customer experience a 5,000-volt electric shock? What will the customer, and we can often break those down into no functionality, over functionality, under functionality, unintended functionality, partial functionality, degraded functionality, or intermittent functionality is one means of breaking those things down. So next, against each of those potential failure modes, we identify, so it's one into many into many. So that's one into many into, so well, it's one into many, one again into many, and one again into many. So this lists are getting longer each time associated with this. So we then identify the cause of this particular failure mode that we've identified in column 3 effects. And we then identify what the cause could. Poor material cause it to break. Could it be designed incorrectly? Could it be overload in use? Could it have been wrongly manufactured? Could it be wrongly glued? So what are the potential causes? So it's one into many. And next, we would then identify what are the controls, quality controls, if you like, that either prevent this error from occurring. It just simply can't happen, or detects it that it's happened. So and we put those reference to those procedures in these columns here, and I do mean reference to procedures. I don't mean that perhaps we do this or perhaps we do that. I actually want to know the particular procedure that actually is preventing this from happening or controlling it from happening. And so that should be linked. So this should be linked to those controls, so we can link them, hyperlink them if you like. Then we can calculate the severity, and the severity is associated with the effects of failure. And we give you this 1 out to 10 scale. And again, this is layers again. I'm going to go into a little bit more detail in a few minutes and to overview this in a few more minutes. So we then link severity using our 1 to 10 scale. We say how serious. So a 1 would be barely noticed by a customer. A 10 would indicate death or injury. Occurrence, what's the likelihood? Well, it's a 50-50 shot. This might or might not occur, so it's a 10. Or this is unlikely, it's a lottery number. It's very, very likely to unlikely to occur, so we give it a 1. And I'll show you these numbers in a minute. Detection, so we link these to controls. From this detection mechanisms, methods that we've identified, what is the likelihood of us detecting? We absolutely will find it. It's a 1. We don't do any checks for it. We don't do any tests for it. We don't do any evaluation for it. Therefore, it's a 10. We can then multiply those numbers together. So severity, worst case scenario is a 10. So it's a killer. Likelihood of occurrence, it will occur during some lifetime, so it's a 10. And we don't test for it, we don't check for it, so it's a 10. So worst case scenario, the risk priority number would be 1,000. So the best case would be severity is 1, the customer wouldn't even notice it. Likelihood of occurrence, it's a lottery number, it's 1 in a million, it's never ever going to happen. And so we give it a 1. And detection, anyway, we test for it, we check for it, we've got those procedures. So it's 1 times 1, which gives. Okay, just checking to see if anybody's still awake out there. So 1 times 1 times 1 gives us 1. So best case scenario is a risk priority number of 1. Okay. Let's so that's the form completed. We haven't done the follow-up of it, but I'm going to go in a little bit more detail again, another layer down, just to overview what I've just been saying to you. So the inputs is to this process is the product specification, field information, product information, literature, drawings, etc. And the deliverable from that will be a completed FMEA form. The logistics means that we've got to get these samples and drawings and customer brief and field failure information, etc. All of that information together to do it. We then complete our header details on the form, the revision numbers, the part number, the name and system that we're going to study, and then we identify the function of the part using that verb 9. Remember the screwdriver? And then we complete the form. How could the product fail to complete its intended function? Can it simply the converse of the product function? So transmit torques will not transmit. But we might want to list all those potential break, bind, corrode, wear things down in that column. The effects of failure then, what would the customer experience as a result of this failure? Will the customer, the vehicles fail to start? Will the vehicle fail to stop? Will the brakes fail? Will the customer experience a 5-volt electric shock, 5,000-volt electric shock? What could bring about this failure mode? And so for each of those failures, we need to identify then that failure mode. And we can brainstorm though, if it's a team, or as you might be just sitting singly by your desk, just doing for the FMEA for yourself and getting the team to evaluate it afterwards. So we will brainstorm those failure modes. And then we did need to estimate the frequency of occurrence, the severity of failure, and estimate the risk, the detection of failure, and then we can calculate our risk priority number, multiplying those three numbers together. Then we need to establish for those higher risk numbers what the corrective action is and take some follow-up. So let's have a look at those numbers in a little bit more detail. So estimate frequency of occurrence of the failure. A 1 is, like I said, a 1 in a million shot, through 2 to 3, 4, 5, down to 6, which is 1 in 80, to 10 is a 1 in 2. So frequency of occurrence of failure, what is the likelihood? And there we've got these numbers again, 1 to 10 numbers. Severity, so 1 would have no effect, 2 would defect was noticed by discriminating customers, through to 9, endanger customer without warning, with a warning, sorry. Failure would 10 would have endangered customers without warning. And then we've got the likelihood of detection. A 1 would indicate certain to be detected. We've got controls in place, through to 10, which would be current controls will not prevent or detect. There are other tables for this, but I personally wouldn't move away from these. These tables have stood the test of time. You can use different ones, but it means that your numbers won't be the same as everybody else's, and you can't compare like with like. Then we need to identify what we're going to do, identifying the high risk numbers. Anything above 100, maybe. It depends. It's very product dependent. This the worst number I've ever seen was around about, I think it's about the worst number I've ever seen was about 400. That was for a seatbelt manufacturer. That was about the worst number I've ever seen, and obviously that was very serious, and we had to do something about that quickly. So I need to identify responsibilities for taking further corrective action, monitor that progress, and perform a further FMEA on the results. So in other words, once we've put those checks and balances in place, what are we going to do? We need to do a further FMEA to confirm that we've reduced the risk and confirm that the action's been taken and implemented fully effectively. Okay, process FMEAs then. So that's a design or product FMEA. This is a process FMEA. So it's basically exactly the same, except that we need to understand the product part function again. So which process are we going to select? So sales order processing, manufacturing, installation process, a project process. I always say with regard to doing FMEAs on projects, don't bother doing FMEA on projects, because it's not worth doing FMEAs on projects, because it's so much more exciting to let the project run and then rush around after the project has gone wrong for all those things that have gone wrong with it. You could have picked up with an FMEA in the first place. So it's far more exciting not to bother doing an FMEA with projects, because it's you can get really hyper when the project's running then and identify all these risks you should have identified with your FMEA. So anyway, we need to identify the process or project that we're going to do our FMEA on, and rather than describing the function on the function column, we put a list, and I'll show you this in a few seconds, a list in that function column of all the steps in the project, all the steps in the program, all the steps in the process. We list out all those process steps, and together with that, describing the function of that particular process step. And then when we come to looking at the primary secondary function, so for example, it could be transport part, and the secondary function could be safely without damage and things like that. We need to look at pre-process characteristics like perhaps soldering iron temperature, circuit board failure, And then we look at the failure mode is how could the process fail to achieve its intended function? And then we look at the effects of failure. So the effects of failure, there's some debate over this. I'm pretty clear about it, but there's some debate. Some people prefer it's the deliverable being the output from that particular process step. And so what's the effect on the customer being the next process step along? I think that's too narrow. I believe it's got to incorporate the customer and the effects on the customer as well. So it needs to do both, I believe. So this is how it changes. And on the diagram here, we've still got to do the header details, and we've got to include the process function. So we list here all the steps associated with our process 1, 2, however many, and also describe using verb noun approach what they're. And then we've got fail to meet the intended process function and the effects on both the process and the customer. So yeah, and we use the same 1 to 10 scale that we used previously. There's no change there. There's no change here. There's no change here. This remains the same. And this is an FMEA of contact lens manufacturer. It happens to be quite a poor one, and I use it as an example of an FMEA so that you can do a study of an FEA quite easily and say, well, the FMEA has been done properly and this one's not been done very well. But I'll save that for another day. So these, you can see, these are the various steps associated with the process, part of contact lens manufacture, and they describe what's going on with that process. There are other risk analysis techniques around. There's HAZOP, HACCP, FMEAs, fault tree analysis, and the rest. So there are others around, but by far the most popular one is FMEA. But there are others around. Just pop it into FMEA into context now for a few minutes. So it's not a standalone thing. It does need to be formed part of planning approach. And here we've got our advanced production and quality planning overview. So we've got concept, initial program, prototyping, pilot and launch, and we've got product design and process design in here. So this is APQP. It's going to be the subject of a lecture, webinar in the future, but it's not. I'm not putting it up for that reason. I'm just showing you this because associated with this is a number of documents that need to be created, and so we can see in here that FMEA is an integral part of the overall quality planning process, and we need to create these documents associated with our quality planning process, and FMEA is an integral part of that, fundamentally important part of that process. Okay, so where have we been? Well, it's a quick tour of understanding that FMEA has been a preventive approach. I think we've got that message now. You understand that it's something we do beforehand, not after the event, although some people do see it as part of root cause analysis. I'm not sure that it really works on that level. It's something that we would want to do. And I think that's why I was saying it's so important that we try and make sure that we build it into as a policy statement from management that we must, if we're going to do a significant change to a product or process, that we must do or a new project, that we must, it's part of policy that was a significant project, a significant process change, a significant new product, it's part of policy management that a FMEA must be required. So it gives us the power, if you like, as quality people to check, to see and support that as well in terms of conducting their FMEA. Hopefully you've understood the importance of FMEA. Again, don't bother doing it. It's so much more exciting to rush around after the event, isn't it? Let's not bother doing risk assessments. We don't need them. Aware of how to conduct a product or process FMEA. So you should have an awareness of that. I think you need a bit more information and detail on it, but okay, you've got an awareness of it. Should understand the individual's roles and responsibilities for FMEA, and perhaps even you might like to consider an action list as a consequence of this course as well, this webinar as well. Just remember that there are further training courses should you require them. There's the distance learning ones that we do that are available through our website, and go and have a look there at our website if you wanted to check on any other information. So yeah. So if you wanted to check on any of the information, just go and have a look at our website. I need to unmute Mary Claire, so just give me a second while I do that. Hopefully I can do that. No, I don't seem to be able to do that. So I'll have to find a way of working around that in a minute. So understand individuals' roles and responsibilities. We should have got that. And yeah, we were talking about creating an action list. So if you want to contact us going forward, then here's some contact information. So if you want to send us an email or anything like that, or go and have a look on the website, www.qmt.co.uk, and there you'll find the information that I was talking to you about distance learning courses, or the open courses that we can do at the moment.